Hi, this is Amprasad. Today we are discussing about ion exchange chromatography. So the process of which a mixture of similar charged ion can be separated by the using an ion exchange resin. So ion exchange resin like a exchange ion according to their relative affinities. There is a reversible ion exchange or similar changed ions. So mostly similar charged ion like cations or anions can be separated by the technique. So reversible exchange of ions between the ions present in the solution and those present in the ion exchange, cations and some of the anion separations like the solid, and the actions are retained by the solid matrix of the ion exchange. So resin can be elucidated to the buffer in the different strength, and hence the separations of cations can be affected. So anion separations of anions using the anions exchange resin solid, and these are the things solution and solution. These are the anions retained by the solid mixture matrix ion exchange resin can be eluted by the using buffer with different strength. So classifications of resins according to the chemical nature: one strong cation and one strong anion resin, and one weak cation exchange resin, and weak anion exchange resin. So according to natural cations and geologic and clay, it is anions is dolomite. Synthesis of inorganic and organic resins. Organic resins are the most widely used argon ions ion exchange resin. The polymeric resin matrix contain exchange sites. So the resin composed of polycystine and divinyl benzene, and polycystine contains the sites of for the exchangeable functional groups. So divinyl benzene act as a cross linking agent, offer the adequate strength, so like mechanism stability. So functional group present in the different ions exchange, and strong cation exchange resin is the and weak anion exchange resin, and strong anion exchange resin and weak anion exchange resins. So common ion exchange resin cations and cat ions weak. Some of the nature and pH and applications: alphanamide and polycystine is the cation strong, and cation weak are the carboxylic methylist. Some of the anion strong, anion weak resins. So structural types of ion exchange resins. So the pellicular type of ion exchange film, and porous resin coated with the exchange beds, and macroreticular resin beds. Surface the sulfonated and bonded electrostatically with anion exchange. Structural type of ion exchange resins. So pellicular type of ion exchange film, and porous resin coated ion exchange beds. Some of the macro reticular resin beds, and surface sulfonated and bonded electrostatically with anion exchangers. So physical properties of resins: particular size will be 50 to 200 mesh fines and powder, and cross-linking and swelling. The when more cross-linking agent is present, they are more rigid, and but the swell less. When swelling is less, separations of ions of different size is difficult, as those cannot pass through the porous present. So when less linking agents present in there are less rigid but swell more, separations will not efficient, as exchange functional groups does not take place due to the wide pore. Hence an optimum quantity of cross-linking agents should be added to the polymeric ion exchange resin for the separation to be effective. Some of the practical requirements like column materials and their dimensions: glass, stainless steel, or polymer which resistant to strong acids and alkalis. Length or diameter ratio and 20:1 or 200:1. So selections of ion exchange resins and depend upon the through the ions to separated natures of the ion exchange separated, and strong and weak cations and anions. Efficiency of resins measured by the ion exchange capacity. Ion exchange capacity is totally ion exchange capacity in the terms of the exchangeable functional groups expressed among the milliequivalents per grams. So ion exchange is resins. Particular size of 50 to 100 mesh, that means 100 to 200. Structural type of resin: porous and pelliculars. So amount of cross-linking agent is present in which decides the swelling of the resin. So packing of the column: wet packing, and the resin is mixed with the mobile phase and packed in the column uniformly. The sample to be separated is dissolved in the mobile phase and introduced all at once into the column. Mobile phase organic solvents are less useful and they are not used at all. Only different strengths of acids, alkalis, and buffers are used as elution of solvents. So development of chromatogram and elutions of isoelectric elution techniques and gradient elution techniques. So analysis of the elute and spectrophotometric method and polar organic method and conductometric method and amphiphotometric method, film photometric method and radioactive film photometric method and geometric method. So regenerations of the ion exchange resins and factors of ion exchange separations like nature properties and ion exchange properties, some of the base size size and ions and polarity and the concentration of solutions and concentration of ion charges. Some of the applications like softening of water and demineralizations of deionizations of water, purifications and some of the solutions to be the form of ionic impurities, separations of the inorganic and organic separations, mixtures of pharmaceutical compounds can be separated. Biochemical separations like isolations of drugs and are metabolically from blood, urine, and concentration of ionic solution. Thank you. Today we are discussing about the ionic exchange chromatography. So what are the functions, what are the applications, what are the principal procedure, and all those we are discussing about today. Thank you. Thank you very much.